Yes. The last day
Yes,
final
sir.
mark. One yes.
Yes, sir.
Yes, आपके टॉपिक कंप्लीट हो गए.
जी सर.
Yes, start कीजिए. Let me start. Basic introduce yourself.
Yes, sir. Sir, I am Siddharth Ratto. I belong to Purulia district of West Bengal. I did my 10th from Barampur Fulchand High Secondary School. After that, I have completed my 12th from Rangadi Sri Bhajanashram High School. I have graduated from Jhagaram Raj College in the year 2021 under Vidyasagar University. After that, I have completed my M.Sc. From Vidyasagar University in the year 2023.
Yes, good. Yes, your name is Siddharth. Explain briefly. How do you feel about your name?
My name Siddharth is comes from two words in Sanskrit, uh, one Siddha and one Artha. Siddha means who has achieved, and Artha means the meaning of something here, the meaning of life. So the meaning of my name is who has attained his goal.
Yes, your interview date क्या है?
Is that
Your interview date, BRC interview date.
the fourth March?
Your next go through on your hobbies. Your hobbies is reading books. Yes. Describe your hobby,
Yes,
daily routines
sir.
in a hobby, how to use it
Movie,
in a day, week, and month.
sir. The hobby watching movies. Sir.
Watching movie. Yes,
Yes,
explain.
sir.
Describe your hobbies, how to use it in a day, week, month.
Mm, sir, I mm, mainly watch like science fiction movies and adventure movies in weeks.
Yes. Next, your native place, Perolia in West Bengal. Yes, explain. How do you feel about your district and your state? Explain briefly.
The Purulia district is mainly under Chodnapur Malbhumi, Chodnapur Plateau, and it has many rivers have passed through our district, like Kamshavati and Kasai, and the famous the thing that is Purulia is famous for is its show dance, that is world famous, and also the picnic spot and picnic and tourist spot, uh, Ayodhya Hill.
Yes. Next is why will you become a PRC, scientific assistant in PRC? Explain.
Mm, Sir, as a student of as a science student, I always wanted to work in the field of research and applied chemistry, and also I wanted to join the defense, and by joining BRC, these two goals of my life can be achieved in a so that's why I'm That's why I wanted to join BR.
What's the role of student training in BRC?
Uh, the role of the role of any chemical student, chemical researcher in BRC is mm, to apply his knowledge, his fundamental and applied, the fundamental and applied research.
Yes, what is BRC? How do you feel about BRC, Bhabha Atomic Research Center? Explain briefly.
Where Bhabha Atomic Research Center is India's premium research institute, nuclear research institute. Its headquarters is in Bombay, Mumbai. It was established by Sir Homi Jahangir Bhabha in the year 1954, January 1954. At the time, the name of the institute was AEET, that is Atomic Energy Establishment, Bombay. It operates directly under the DAE, that is Department of Atomic Energy. And the present director of BRC is Sri Vivek Washing. The motto of BRC is atoms in the service of nature.
Yes, good. Next, move on your topics. Your topic is chemical kinetics. Yes, kinetic theory of gaseous state, thermodynamics, OMC, and physical spectra. Yes.
Yes, sir.
So first of all, what is the main application of chemical kinetics? What the beneficial chemical kinetics in our life, in human being, in our society? Explain. 5-10 point.
Sir, firstly, the name chemical kinetic itself tells about the chapter. So, chemical kinetics, chemical related to the some chemical reaction or chemical changes, chemical reaction or chemical change, and kinetics, how fast or how slow the reaction occurs. So, uh, speed of reaction, fast or slow, it's the kinetics word tells us. So, from chemical kinetics, we study the rate of reaction of many reaction. So, rate of reaction to measure the rate of reaction is measurement of rate of reaction is very important due to in our industrial field where if we can obtain product in less time, that will be beneficial uh, for our work and our daily life. So that's why we study chemical kinetics.
Yes, what the difference between order of reaction and thermodynamics? Law of thermodynamics. Explain. 4-5 point. Order of reaction. Yes, 0, 1, 2, 3. And law of thermodynamics 0, 1, 2, 3. What the difference? Explain. Interconnected.
The order of any reaction on that law of thermodynamics. So the order of reaction tells us about the relationship of rate of reaction with the concentration of the reactant. Concentration of reactant. So for a first order reaction, the rate, that is we can write as dc by dt, is directly proportional to the concentration. So the rate constant K into concentration of C. So here rate is linearly varies with the concentration. Now for a second order reaction, rate is proportional to the concentration square. For a third order reaction, rate concentration cube. On the other hand, the law of thermodynamics, at first the zeroth law. Zeroth law tells us about if two bodies are in thermal equilibrium with another third body, then they will be in thermal equilibrium with themselves. So if I say A and B in thermal equilibrium with C separately, so in thermal equilibrium, so then A and B will be thermal equilibrium with themselves. This is the zeroth law. Now first law is mainly the conservation of energy. So and first law tells us about the conservation of energy, that is energy neither be created nor destroyed. It can be converted in one form to another form. And the second law mainly tells us about the concept of entropy, where that heat cannot completely converted into work. Completely converted into work. So these are the laws of thermodynamics and the order of reaction.
Yes, carry on.
For first order reaction, A soda. So in this case, ln A by AT will be AT. That is A2 is into A0 e to the power minus KT. This is the first order. Second order reaction, 1 by AT 1 by A0 will be equal to KT, and third order reaction will be 1 by 80 square minus 1 by A0 square into KT. So this happens as integrated rate laws.
Yes, good. Yes, good point. Next, move on. What the difference between collision theory, activated complex theory? Yes, activation theory. Explain what the difference. Activation, collision, activated complex Einstein state theory.
Yes, sir. So the activation theory. So the RNA, this is called the Arrhenius theory. Arrhenius suggested gives the relation between rate constant with temperature via this equation where K is the rate constant, A is pre-exponential factor, E is the activation energy, and if we plot ln K will be ln A minus EA by RT. So if we plot ln K by 1 by T, there will be a straight line. And by extrapolating this, we can get ln A, and from the slope, we will get minus EA by R. So activation energy can be calculated from this graph. After that, the collision theory. Uh, in this case, the rate or rate constant is dependent on three parameters, that is the collision frequency or collision parameter Z1 2 into the e to the power star by RT, and another steric parameter, that is P. So Z1 2 is pi sigma A P square. If two different gas molecules are there, so 8 RT by pi mu into and A and B. So this and B, this is rate. Yes, this is rate into e to the power minus EA E star here E star by RT into P. So rate constant K will be pi sigma AB square root 8 RT by pi mu into e to the power minus E star by RT into P. So P is the steric factor. So from here we can get the idea that K is equal to A into T to the power half into e to the power minus E star by RT into P. P is the steric parameter, and from this equation, if we want to calculate the activation energy, so it will be this ln K, so ln A plus half ln T minus E star by RT plus ln P. So d ln K by dt, that is 1 by 2t minus E star by RT plus E star by R. Plus E star by RT square. Yes. So this is equal to A by RT square via Van't Hoff equation. So this will be RT RT square, and this is RT plus E star. So A will be E star plus half RT. So this is the relation between activation energy and this is the threshold energy. So from collision theory, we get the idea that the pre-exponential factor is also temperature dependent, and we get the activation energy in this form. Now, the activated complex theory.
Yes.
The activated complex theory, here A plus B is in quasi equilibrium with the transition state AB dagger lead to product P. So this is K1, K2, K3. So K dagger will be K1 by K2. That is will be A, the concentration of B. Now A B dagger will be K dagger, concentration of A, concentration of B. Now rate will be K3 into concentration of AB dagger. Now replacing this K3 K A, concentration of B. So A0, concentration of A, concentration of B. Now rate is equal to, this is the conventional rate. Now if we solve the derivation, we will get the K or rate constant equals to A into T to the power 1 into E to the power E by RT. So here the T exponential factor and is dependent on the temperature also, and the E will be E plus RT.
Yes. Next is what the difference, what the uses of slow reaction and fast reaction chemical kinetics?
What is the relation between?
Application of slow reaction, fast reaction, and chain reaction, and conjugative reaction, and parallel reaction. Explain. One by one point.
So slow reaction, application of slow reaction. So we can measure the rate of the reaction has these slow reactions, and whereas the for fast reaction, the rate determining process is rather used as flash photolysis. Application of consecutive reaction. Consecutive reaction is if a reaction goes through a intermediate. So if the rate constant of first step is less than the second step, we can apply the steady state approximation. And this is the rate of product formation. This is in A, and if the rate of formation of intermediate is low, so we can take it as a constant. So di by dt always 0 second, and from this the solve from this we can solve the rate equation more easily.
Yes, good. Yes, what the limitation of chemical kinetics in thermodynamics? Explain.
Limitation. So chemical kinetics. The major limitations of chemical kinetics is the study of very fast reaction is cannot be done more easily. So chemical kinetics cannot give equations for very fast reactions. Then the chemical kinetics, there are some reactions pseudo fast order that explained as second order, but it is actually to experiment it behaves like first order. So and thermodynamics. As our system becomes complex, we as the system becomes complex, the physical properties, we cannot measure the physical property more easily, and del we need some auxiliary functions like delta G, delta A to explain feasibility. That is not in any one of the great laws of thermodynamics.
Yes. What is Maxwell relation? What the main application of Maxwell relations in thermodynamics? What the limitation of Maxwell relations in thermodynamics? Explain.
The Maxwell from the Maxwell square, we can easily derive the Maxwell's relations. Here du can be written as TdS minus PdV. dH is dH is PdS plus VdP. dT is VdP minus SDT, and dA is minus dt minus PdV. So each of these four equations we can write as these are exact differentials. So these are on of the form mdx plus ndy. So we know from this dm by dy at constant x will be del m del n by del x at constant y. This relation will hold in each one of these. So del t by del v at constant x will be minus del p by del s at constant v. Similarly, del t by del p at constant s will be del v by del s at constant p. So these are the Maxwell relations, and from this we easily get the values, the change in temperature, volume, entropy, and pressure change. We can easily correlate each other.
Yes. Yes, limitation of Maxwell relation in thermodynamics.
Limitations, yeah, limitations पढ़ना पड़ेगा.
What is Joule-Thomson effect and Joule-Thomson coefficient? What is the difference? Main application in thermodynamics.
Joule-Thomson coefficient, or Joule Thomson effect. So this is the Joule Thomson coefficient. Yes, Joule Thomson. So Joule Thomson mu Joule Thomson is equal to change in temperature with change in pressure at constant enthalpy. So the Joule Thomson expansion occurs Joule Thomson effect. Joule the expansion of gas of gas occurs. So here dP is always negative. Change in pressure as gas expands, the volume increases. So dP as a change in pressure will be negative. So if mu Gt is negative, so that tells us about so if it is again negative, so dt will be positive. So T2 minus T1 is positive, T2 greater than T1. So there will be heating. And if mu Gt, that is Joule Thomson coefficient, is positive, so as dP is negative, dt will also have to be negative. That is cooling of Earth.
Yes, good. Yes, good point. Next is what is Carnot cycle? The main application of Carnot cycle. And what is the graph of Carnot cycle in PV and TS? What is the limitation of Carnot cycle? Explain one by one point. Yes, this one good. Yes. Next. Move on Carnot.
Carnot cycle. So Carnot cycle explains Carnot cycle is a reversible cycle, consists of 4 steps. That is PV graph of Carnot cycle. So isothermal reversible expansion, reversible isothermal expansion, reversible adiabatic expansion, then reversible isothermal compression, and this reversible adiabatic compression. So this is the PV diagram of Carnot cycle, consists of 4 steps, that is from A, B, C, D. So in the TS diagram, if you plot TS diagram, it will be box, that is reversible isothermal expansion. So temperature will be constant. This will be the A, B, reversible isothermal expansion, and adiabatic expansion. So no transfer of heat, therefore entropy will be constant here. So B to C, reversible adiabatic expansion, reversible isothermal compression,